Hello, I'm A Hilmy, a final year student in software engineering. My final year research belongs to the NLP area and it is based on performing aspect based sentiment analysis on comparative reviews to identify product weaknesses. In simple terms, it is trying to find product weaknesses by analyzing comparative feedback given by consumers on an aspect level. So let's start with a quote. Your most unhappy customers are your greatest source of learning. This is taken from a book written by Bill Gates. So, with this, let me give an introduction or a little background to the research. So, people often use a product to fulfill their needs and expectations with the help of the functionalities it offers. But a negative experience with the product makes them look for a better alternative available in the market. Due to this disapproval of their product owners lose their share of the market. So, with the introduction of Web 2.0, it has been much easier for people to provide feedback in the event of such experiences. These reviews could be either in the form of direct opinions or comparative opinions. Therefore, through this research, we intend to introduce an automated system to find product weaknesses in an attempt to support product owners to find the causes of dislike or disapproval of their product, which will also aid in eliciting customer requirements directly from the customers so that they can identify what or why does their competitor's product seems more attractive to their customer than their products, and probably retain or regain their customers who may otherwise look for alternatives in the market. This will help the product owners to find the aspect of their product which attracts existing customers and aspects which keep away people from buying their product also. Companies who are interested in knowing the reasons behind negative or neutral reviews and who are interested in understanding the loopholes in their products or services will be benefited by this software outcome. This is a little overview to my project. The recent progress is that, of course, I've identified the research gap and reviewed the literature. Then requirements were also elicited. Currently, I am in the initial phase of system design and the initial phase of implementation. So, the goal of the project is to introduce an automated system that identifies comparative weaknesses of a product from customer feedback. Next, we'll look into the research gap. So, first, I looked into existing literature on weakness identifiers. These are some of the weakness identifiers I found. So, existing literature about these weakness identifier systems focus on individual product reviews rather than comparative reviews provided by customers. Even in identify weaknesses, what they have done is using individual product reviews separately and analyzing the number of weaknesses mentioned in them. From my point of view, I think there's a higher probability that a comparative review provides an unbiased experience by an individual, meaning that the customer has some level of experience with both products subjected to comparison. Again, it can be a more accurate approach in finding the exact reasons for rejection of the product and the consequent decline in customer base. This opinion was supported by domain experts during requirement elicitation. Therefore, we could go ahead with analyzing comparative reviews because they found it to be an unbiased approach to find the exact reasons. And next, we'll see why sentiment analysis alone is not enough. Sentiment analysis provides a very high level idea about customer satisfaction ratio, just the customer satisfaction ratio. So, since sentiment analysis is not capable of identify the exact cause of customer dissatisfaction, aspect-based sentiment analysis could be used here because this will help to know the root cause of declining sales in detail. So, like I said before, it will help companies who are interested in knowing the reasons behind negative or neutral reviews. And next, we'll see why comparative reviews are better. So, comparative reviews are usually in this format, like in the example, Facebook's theme is better than Twitter. Here, two different entities are compared directly, but in the case of using individual reviews, you will have to collect them separately and then identify which one is weaker. It is not accurate if you collect the number of weaknesses mentioned under one product and then get the count of it and say that this particular product is performing better than the other. So it's better if you can use an unbiased approach, since this particular review, for an example, is written by a single user or is an individual. The source of this review is the same individual. So he's comparing both of these entities at the same time. There are no other factors which would influence this review. The other advantage is, as I mentioned, it is an unbiased approach to identify the weaknesses, and product owners can directly address the pain points. These were also mentioned during the interviews with domain experts. Next, I looked into existing literature on comparative reviews. Here, most of these researches are based on comparative reviews in English and Vietnamese, then Arabic, Portuguese. Most of these were based on traditional machine learning models. The other thing is that data set was small. In order to improve the model's accuracy and performance with a lot of data, and additionally trying to perform sentiment analysis on an aspect level is the research gap I've identified. Apart from this, I've referred other literature on mining comparative sentences and classification of comparative preferences related research. Next, we'll look into the proposed solution. Okay, so this is a concept map I've composed. Most of these categorizations are based on existing literature. Opinion analysis is same as sentiment analysis, so there are three different levels you can perform sentiment analysis, of which I choose aspect level. And there are three different kinds of opinions, from which I've chosen comparative opinions here. And the issues are aspect extraction. Due to the language complexity and grammar, it hasn't been perfect. The other thing is the language which I'm going to work on. I'm working on PO languages, and that too in English. There are two other kinds of languages found in sentiment analysis related researches, and the domain I'm working on product reviews. Approach is going to be deep learning. Then for the algorithms, I'm using neural networks, and it is a CNN neural network currently I'm working on. And for evaluation, I'll be using the popular confusion metrics and perform a cross-validation evaluation also. Then this is the architecture diagram of system. There'll be four main views in the website. So in the second page, we'll be collecting the inputs, and then there will be a data processing module where the data will be cleaned at that point, and then it'll pass into the weakness identifier, where first there'll be a comparative sentiment prediction happening there. Then from that, it'll move into the aspect extraction module, where the aspects will be extracted, then from which we will analyze the weaknesses and identify the weak features from there, and display it in the analysis report screen. And in the data layer, we will have the model, deep learning classifier model or neural network model, with the training data we've used for training the model. Next, we'll look into the core functionalities. The key areas I'll be discussing here are data preprocessing, comparative sentiment analysis, and aspect extraction. In data preprocessing, I'll be showing how I visualize data and handle the class imbalance. And under comparative sentiment analysis, I'll be discussing how globe embedding was used to create an embedding matrix for our corpus, and the RNN and CNN models that were developed. Then under aspect extraction, I'll be showing how aspects were extracted using the pre-trained DOS tagging pipeline in library. In this notebook, I'll be showing how data preprocessing was done. First, I'm importing the libraries. Matplotlib is used to show the class distribution, and pandas will be used for data manipulation and analysis purposes. First, I'm loading the initial dataset into a data frame. There are 12,000 records in the initial dataset. Then here I'm finding the different types of polarity labels found in this dataset. So there are 9 different polarities here. I'm filtering these 3 polarities because these equal comparisons, which are denoted as pos, new, and neg, will not help us in finding weaknesses. Therefore, I am filtering these 3 out, and we have 6 other polarities remaining. So from this, I am finding the number of records pertaining to each polarity. So here we find that there are 5,000 plus records for pos neg, and we have 1,426 records for neg pos. If you filter these out, pos, neg, and new, the rest of it are having a very few number of data. So in this research, I'll be using only pos neg and neg pos reviews. Here I'm filtering them because there was a less number of reviews for the other polarities, which can be used in identifying weaknesses. But then since the data set is small, I'll be using only pos neg and neg pos reviews here. This is that filtration process where I filter only pos neg and neg pos reviews, and I'm saving it into CSV file, and I'm loading that again into a data frame. Here we can see we have 5,229 pos neg records and 1,426 neg pos records. This is the data distribution. So here you can see there is a large gap between the number of records among 2 classes. Therefore, I am undersampling the records in the abundant class. I'll be considering the first 1,426 records in the data set and filter them. So you can see there is a large gap between the class distribution. Therefore, I am undersampling the records by considering the first 1,426 records, which is an equivalent of the number of neg pos records, and filtering the pos neg records which belong to the first 1,426 records in the dataset, and this will result in 1,143 pos neg records. Here we will get the same number of neg pos records because we are not filtering anything here. Now if we plot the class distribution, we get this result, and now the gap between the classes, and here the gap between the 2 classes is less. So now here we can see the gap between the 2 classes is less, and then we are converting these labels into binaries. Pos neg is labeled as 0, and neg pos will be labeled as 1, and here we are saving that into a CSV file. In this notebook, I'll be showing how the classifier was developed. So here in this cell, I'll be importing all the required libraries. I'm using NumPy, Pandas, TensorFlow, Matplotlib, and Keras from TensorFlow for pre-processing and model development. Then I'm using scikit-learn to split the data into train and test partitions, and from here I'm reading the dataset and loading it into a data frame. So the length of the dataset is 2569 record. Here I am getting the review column into a variable x and the polarity column into a variable y, and next see how tokenization happens. Here I'm giving a max text length of 400 because the length of the reviews in this dataset is not that long. I'm going for a shorter value, so 400 is what I've chosen. Then I'm initializing the tokenizer from Keras text and performing the tokenization and creating a vocabulary. The length of the vocabulary is 1345. We are converting the text into sequences and padding the sequences until it's 400. In this, we are creating an embedding index out of globe embedding. First, we are reading the globe embedding file. For each line in the file, we are splitting the line into an array of elements, and the first element is the embedded word, and the rest of it is going to be the vector representation of the words. So those are the coefficients attached to this word. We are creating a dictionary out of it, and we are passing the word as the key, and we are assigning the coefficients as the value. When the file is read, we end up with 400,000 word vectors in the embedding index. This dictionary has all the words available in our dataset. Now we are creating an embedding matrix for our vocabulary, our dictionary, with the help of globe embedding. The globe embedding we are using is a 100 dimension embedding, so I'm using 100 as the embedding dimension here. And the vocabulary size we calculated be 4345. We are creating an embedding matrix by initializing it with zeros. For each word in the tokenizer, we are checking if the index is greater than vocabulary size -1. If not, we are getting the embedding vector associated with the word we are searching for, and we get the vector representation from the embedding index created. If the embedding vector is not none, then we'll be assigning that value into our embedding metric for model development. I'm using these values for these parameters. These are some models I've developed before. I found this to be a little complex because the dataset isn't sufficient. If I quickly go through this, I'm creating a sequential model with the embedding layer. Here what I'm using is LSTM with the activation function sigmoid. In the second model, I'm using an additional layer, visual dropout, and here I'm changing the activation function into softmax. There's another model where I'm using different layers with bidirectional LSTM and a dense layer, then a dropout layer, again a dense layer with a dropout layer. Activation functions used here are ELU. This is another model again with LSTM and softmax as the activation function. So I created a model with CNN layers. Here again we have the embedding layer with a dropout layer. Then there's a 1D convolution layer, the activation function ELU, and there's a max pooling 1D layer. And there's another convolutional layer and a global max pooling layer, a dense layer, all these with ELU activation function. Finally there's a dropout layer and a dense layer. I'm using TensorBoard to save model training logs. Here I'm using Adam Optimizer with a learning rate of 10 to the power of -6 with binary cross entropy as a loss function because this is going to be a binary classification, and passing the optimizer I've created before, and passing accuracy as the metric. Here we are splitting the training and validation data set which we have tokenized and prepared before with a test size 0.3. We are giving a batch size of 32 and 100 epoch. Now we are training the model with this batch size and 100 epoch. Validation data will also be passed, and we're passing the TensorBoard callback. Let me run for the first 10 epochs. We can see that the training losses are reducing, accuracies are increasing. Same goes with validation loss and accuracy. During the last epoch, the training loss has reduced to 0.4, and validation loss also has been reduced to 0.2, while the training accuracy and validation accuracy has increased up to 87%. And here I am plotting the training accuracy and validation accuracy against each epoch, and same with training and validation loss. So this is what the graph looks like. Then I'm saving the model into a file. Here I'm loading the model into a variable, and then I use these tokenizer, max length, padding type, trunk type, all these values, and perform tokenization, converting them into a sequence, then passing the sequence into the prediction function, and predict the sentiment label. If the label is 0, then we would show that it is positive, negative. The first part of this label is associated with the first entity which is mentioned in the sentence, and this will be related to the second entity which is mentioned in the sentence. If the label is 1, then it will be a negative and positive review. These are two sample predictions. Loading speed is higher than Twitter, which means Facebook is positive and Twitter is negative. Then in this sentence, it is hard to get anyone's attention on Twitter, which means Twitter is negative when compared with Facebook, which is positive. In this notebook, I'll be discussing how aspects are extracted from comparative sentences. For this, I'm using the Spacy library. First, I'm loading my pre-trained model into a variable, and I'm loading the pre-trained English model from Spacy library also into a variable. And here I'm giving a sample sentence. Facebook theme is better than Twitter. And first, we are finding the sentiment. We are using the tokenizer, giving a max length of 100. Padding type is given as post. Trunk type is also given as post. And this is a function I've created to predict the sentiment. Here, first we'll be tokenizing the sentence and padding the sentence based on these given values, and we'll be predicting the sentiment label, and based on the result we'll be showing that the review is positive, negative, or if it's 1, we'll be showing that the review is negative and positive. Here we are returning the label, and we are calling this function on that sentence and predicting the sentiment. So this will return the label. First let me run this and predict the sentiment. We can see that Facebook theme is better than Twitter, which means Facebook is positive and the label is 0. This is an algorithm I've developed to extract aspects. Here we are checking if the syntactic dependency is an end subject, and the post tag of the token is a noun. If these two conditions are met, then we will consider that this is the target aspect. If the POS tag of the token is an adjective, we'll be checking if any of the children of the token is tagged as an adverb. Then we'll be determining the descriptive term based on that and return the aspect with the description. So for our sentence, which is Facebook theme is better than Twitter, we can see that aspect is theme and description is better. So that's a descriptive term which determines that this aspect was better or worse compared to the other entity. Here I have a list of products we have in our training dataset. In this cell, I'm splitting the sentence into an array of words, and here I'm trying to determine the order of products that has been mentioned in the review. So if we take our example, Facebook has been mentioned in the first half of the sentence and Twitter has been in the latter half. So Facebook and Twitter will be the order. Here we'll be determining that if any of these products in this array is mentioned first, then it will be taken as the first entity and the other one will be taken as the second entity. We are storing that product order in the array. If the sentiment is 0, which means it's positive and negative, the first entity is positive when compared with the second entity. We are getting the order of products from this array. This will be the aspect we have extracted. It will be stronger when compared to the second entity. The other way around is the second entity is weaker when compared with the first entity. That's about the first polarity label. And if it's 1, the first entity will be weaker compared to the second one, and second entity will be stronger compared to the first one. Next, let's discuss about the schedule. Now I'll be working on the testing and evaluation report. Then we have to prepare a draft of final project report. Then by this time I'll be reviewing the final project report. We need to proofread it and then submit by the end of April, on the 28th of April. Further, I will have to do proper testing and evaluate the model using other intrinsic metrics. Also get a human evaluation done for the model. Then I will have to prepare the thesis, review and proofread, and then finally submit the project with the report. Thank you.